So Unit 8 is all about using and comparing statistical data. So as a quick review of what we've already learned, we know that there are multiple representations of data: dot plot, plots, bar graphs, and circle graphs. We've already talked about most of these representations. We know to find the shape of a dot or box plot, for symmetry, you cut it vertically in half and see it's the left side near the right. The median of your data is the middle or center of your data. The mode is the data that happens the most frequently. And the range or spread is the largest number with data minus the smallest number with data to find the range or spread. We also know from box plots the 5-number summary. So the minimum and maximum are pretty obvious. They're just in the two extremes of the box plot. The median is the red line right in the middle. It's the middle of our data as well. And then we have our lower and upper quartiles, which are our medians of the first 50% and the second 50% of our data. We've also talked about circle graphs, and we've inferred some information from them. We noticed that when our circle graphs have percentages, but the word problem uses another unit, we know to set up a proportion to convert between units, right? So the circle graph says that comedy is 37% of the students in that film class, but we're wondering, okay, well, what does 37% mean in terms of students? How many students is that, right? So that's when you set up a proportion, equivalent fractions, to say, okay, well, this many students out of 25 has the same value as 37% out of 100%, right? We're setting up equivalent fractions. So today we have two objectives, and you'll see that we have two different representations we're talking about. How many more from circle graphs? And how many more from tables? Ms. Burns, what do you mean, how many more? Well, let's just talk first about that little phrase, and then we'll go into circle graphs and tables, okay? So I'm looking at this, and it says, how many more hearts are there than stars? And you might be thinking, this is really obvious. I'm 12 and 13 years old. I can do this math. It's 2, right? There are 2 more hearts. But I want us to think about the process behind what we're doing in our minds, so that we can break it down when the numbers get a little bit more complicated, right? And the concepts get more complicated. So we have 4 hearts and 2 stars. How many more hearts are there than stars? Well, we have 4 hearts and 2 stars. In math, we subtract to find out how many more. So 4 minus 2, oh, there are 2 more hearts than there are stars. Okay, that's fine, Ms. Burns, I get it, but I want to go ahead and model what's happening here as well. We're basically doing 0 pairs. So for 1 heart, you cross off 1 star. 1 heart, 1 star. Oh, look, I have 2 hearts left over. That's how many more hearts there are than stars. So you can do it with 0 pairs, with subtracting, but that's how you determine how many more there is of something, okay? So again, when we read the phrase, how much more, how many more, in math, we know that the operation we're going to be using is subtraction. So let's go ahead and jump into a problem determining how many more of something with a circle graph. Okay, so let's just read the problem. Tremaine used the computer a total of 30 hours last week. The circle graph shows how Tremaine divided his time on the computer. Okay, so I see his computer time, games was 25%, homework was 20, social media 40, okay. The question is asking, how many more hours did Tremaine use the computer to play games than to do research? Oh, easy, 25% for games, 5% for research. How many more? 25 minus 5, right? Oh, 20, done. Oh, easy, Ms. Burns. Okay, that is how many more, but the unit is percent, 25% and 5%. Oh my goodness, it's asking how many more hours, okay? So we're going to have to, we do find the difference, but then we have to translate that or convert it into hours instead of percents, okay? So we're not done with this problem yet. So we've already subtracted. We know that it's 20% is the difference here. So now I need to set up my proportion to start solving for how many hours they spent, right? Okay, so we know that for proportion, it's part of the group over the whole group is equal to some percent over 100%, right? We're setting up equivalent fractions. So the part of the group that I care about is how many more hours he spent on games and research. Well, we don't know that yet. We don't know how many more yet, but we do know the total number of hours he spent was 30. Okay, so that's our whole group. And then we also know that percent, right? The part of the group that we care about, because we've already subtracted, that's the 20%. So we're saying 20% out of 100%, that's a fraction, right? And we're saying, well, if we were to convert that to hours, how many hours out of 30 hours has the same value as 20% out of 100%? Okay. So we have our proportion written out, and now we're going to solve. So in order to solve proportions, we know that we cross multiply and divide. So I'm going to be doing 100 times x is equal to 30 times 20. Okay, so that's 100x and 30 times 20. Well, 3 times 2 is 6, and then I add 2 zeros on there. So 100x is equal to 600. But we want to know, well, what if we only had 1x, right? We're trying to solve for 1x. What does 1x have to be in order for this equation to be true, for the value of this first fraction to have the same value as the second fraction? So since x is being multiplied by 100, you do the inverse, the opposite, you divide by 100. And whatever you do to one side, you have to do to the other. So now, all we have remaining on the left-hand side is x. 600 divided by 100 is 6. So Tremaine spent 6 more hours on the computer playing games than doing research here. That is what happened. So 100 times x is the same value as 30 times 20. Okay. So yes, so what did we do here? We first subtracted to find the part of the group that we care about. We don't just care about games, or we don't just care about research. We care about the difference between games and research. So we did that first. That's the part of the group that we care about. Then we put it into a proportion and solved the proportion from there. All right. So that was from circle graphs. Now let's talk about finding how many more from tables. Okay, so the example problem says a new school is opening in Round Rock ISD, and the students were surveyed on what the new school colors should be. The results are shown in the table. Okay, I see colors and votes. And the question says, if there are 900 students in the school, how many more would prefer black and white than purple and white? Okay, if there's 900 students, wait a minute. There is no way all of this is equal to 900 students. Because like 50 plus 55, that's about 100. Plus 120 is like 200. That's not 900. So I have 2 different groups happening here. What is this group size? And then apparently we're scaling it up to a bigger group, right? To 900. So when you realize you have 2 different group sizes, oh yeah, okay, so when we add them all up, we see, oh, our group is actually 300. Okay, so we have 2 different group sizes here. Once you realize Okay, I have two different groups I'm working with, a group of 300 and a group of 900. You're going to be setting up equivalent fractions again to see, oh, okay, well, this many out of 300 has the same value as this many out of 900, right? So you're setting up a proportion. You have your current group on the first fraction, and then the new group on your second fraction. Okay, so we'll go ahead and do that. So we know to subtract. So we're wondering black and white over purple and white. Well, that's 120 minus purple and white is 55. So I have to borrow, it becomes 10. Borrow again, 11. Okay, 65. Oh, cool, 65 students, right? No, those are these are number of votes for the first group, right? Out of 300. It is not 65 out of 900. So please don't make that mistake. We're saying 65 people out of the 300, the group of 300, prefer black and white over purple and white. Okay, so now I have that number. I need to set up my proportion. So we're saying, okay, 65. 65 out of 300 is equal to what out of 900, okay? That's what we're trying to determine now. These are fractions. 65 out of 300, a group of 300, has the same value as how many people out of 900? Okay, so there's a couple of ways to solve this. You can cross multiply and divide, or you can use a scale factor. So I'll first just use a scale factor. I know that 300 times 3 gives me 900. So 65 times 3 should give me my my answer as well. So 65 times 3 is 195. So that's one way to do it. Oh, 195 students out of 900. Okay, now your fractions will not always have clean, simple patterns like that. And that's why we practice cross multiplying that way, because you will always get the right answer and be able to see the right answer if we cross multiply and divide. So 300 times x is equal to 65 times 900. Holy cow, 65 times 900. I'm going to go to my calculator for that. That's 58,500. So 300x is equal to 58,500. Okay, well, if that's for 300 x's, but we want it for one x, right? So since x is being multiplied by 300, you got to divide it by 300. And whatever you do to one side, you have to do to the other. So I'm going to divide both sides by 300. And we get x is equal to, let's see, divided by 300, 195. Hey, we got the same answer. Yeah, so it's 195 students out of 900. Okay, so again, the how many more phrase tells me I'm going to be subtracting. Okay, so I have a group minus another group. Okay, and then I found that that's the part of the group that I care about. 65 people out of a total 300. Okay, but then we are translating that into a group of 900. So if we have a group of 300, we have to scale it up to more people, right? So that's why it becomes 195 students prefer. So yeah, circle graphs and tables provide us a lot of information.